convergence, basically when we talk about convergence, we are essentially talking about two different concepts, absolute convergence and relative convergence. So what exactly these concepts mean, let us try to understand. Okay, so I'm sure that all of you by now are familiar with the fundamental Solos-Swan equation given by equation number 19, right? So once you have this equation, what you do is, this is something that you can do. So you can take a partial derivative of k dot by k with respect to k, right? And this would be the expression for the partial derivative, and very easily you can figure out from the assumptions of a neoclassical production function that this term over here, this expression, would be negative, right? So basically what this means is, other things equal, smaller values of k are associated with larger values of k dot by k. So when you start from a small value of capital per labor or capital per worker, then definitely your growth of capital per worker, which is captured by k dot by k, that is going to be higher, right? So this is the underlying idea. Now, an important question that arises is whether this result means that economies with lower capital per person would tend to grow faster in the, in per capita terms, right? So in the long run or medium run, whether economies with lower per capita capital would tend to grow faster than economies with comparatively higher capital per person. So that is the question. So in other words, you can frame the question a little differently. Does there tend to be convergence across economies? Do you find evidence of convergence across economies? This is the more important question. So to answer these questions, consider a group of closed economies. Let's say isolated regions or countries, which you can think of these countries to be structurally similar in the sense that they have the same values of the parameters S, N, delta, like the savings rate, population growth, and the depreciation of capital. These parameters are same for these countries, and also they share the same production function. Okay, so let's call this function, this production function, f of k. Okay, so each of these countries have the same production function. So the economies have the same steady state values of capital and output, capital per worker and output per worker, which is small k star and small y star. Now imagine that the only difference among the economies is in the initial quantity of capital per person, right? So for example, a comparatively richer economy will start from a higher value of capital per person as compared to a comparatively poorer economy, right? So poorer economy will start from a lower value of capital per person k naught, right? Okay, so if that is the case, then the question is, do you expect poorer economy to grow at a faster rate? That is the question, right? So, as mentioned before, these economies have the same parameters, saving rate in terms of saving rate, population growth, depreciation. These parameters are same, right? They have the same production function also. Now, and also they have the same state, because the point of intersection of the production function and the the SFK by K schedule, SFK by K schedule that is determined by the production function and the N plus delta schedule. Point of intersection of these two schedules determine your steady state capital and steady state output, right? So since the production function wise and other parameter wise countries are similar, hence their steady state values of capital and output would be similar also. Let's call these steady state values K star and Y star. Okay, now imagine that the only difference among these economies is that they differ in the initial values of capital per person. So K only difference is in terms of K naught, right? So these difference in starting values of capital could actually reflect past disturbances such as let's say wars or transitory shocks to production functions. So the model then implies that the less advanced economies with lower values of K naught and Y naught have higher growth rates of K and in the typical case also higher growth rates of Y. Okay, so see, the thing is, you are familiar with figure 1.4 of Paracel-Martin, I'm sure. We went through this figure before. This particular figure, not this one, sorry. We'll be coming to this, but before that, let's go back to figure 1.4, this one. See, in figure 1.4, we had distinguished two economies, one with a low initial value of K naught, let's call it K naught poor, and the other with a higher initial value of K naught, let's call it K naught rich. Okay, so since each economy has the same underlying parameters, the dynamics of K are determined in each case by the same SFK by K schedule and N plus delta schedule. Hence, the growth rate K dot by K is unambiguously higher for economy with lower initial value, that is K naught poor, right? So this result basically implies a form of convergence, meaning that regions or countries with lower starting values of capital labor ratio have higher per capita growth rates, which is K dot by K, and thereby tend to catch up or converge to those with higher capital to labor ratios, right? So this is the idea of convergence. Okay, so what is the idea of convergence? It basically means that regions or countries with lower starting values of capital labor ratio, K naught, initial values, that is, have higher per capita growth rates. So lower initial capital to labor ratio implies higher capital per capita capital growth rate. That is a higher value of small k dot by small k. And these countries which have comparatively lower values of capital to labor ratio, these countries actually tend to catch up or converge with the countries with higher capital to labor ratios, because by virtue of having smaller initial capital to labor ratio, their growth rate of capital to labor ratio is higher, right? So alternatively, if you are looking into a country with a higher capital to labor ratio, initial capital to labor ratio, then that country's growth rate of capital to labor ratio would be lower, right? Hence, convergence would be possible. Okay, so now this is the formal definition of convergence. So regions starting from lower values of small k have higher per capita growth rates small k dot by small k, and hence they tend to converge or catch up with those with higher k naught. So this is called absolute convergence, which actually holds empirically for more homogeneous group of countries. We are going to look into it in a bit. So the idea is that, we are looking into a hypothesis in which poor economies tend to grow faster per capita than rich economies, without conditioning on any other characteristics of economies and any other parametric details of economies. So this phenomenon is referred to as absolute convergence. What is absolute convergence? The hypothesis that poor economies tend to grow faster per capita than rich economies without conditioning on any other characteristics of economies. This concept is referred to as absolute convergence. Okay. Now, this hypothesis receives only mixed reviews when confronted with data on groups of economies. Now, we can, for example, look at the growth experience of a broad cross-section of countries over the period I think this is 1960 to 2000. I'll just show you the data. This is, I'm just zooming this a little bit. Anyway, I hope you can see this figure. This is a scatter diagram. So basically what we're doing is we're looking into data from 1960 to 2000. And the capital, see, in the y-axis, what we have done is we've taken the growth rate of per capita GDP from 1960 to 2000. This is the plot that is obtained by looking into a group of economies. Okay, so the time period is from 1960 to 2000, and in the x-axis we have taken log of per capita GDP in 1960. So you can think of these values as initial capital stock, initial capital to labor ratio. Okay, so so this is basically, so these plots, as you would find, these refer to the average annual growth rate of real per capita GDP against the log of real per capita GDP at the start of the period, which is 1960. And we are looking to 114 countries, which is, a lot of countries. It's pretty comprehensive data. So the growth rates are actually positively correlated, as you would find, see, a slight increase, a slight upward slope in a positive slope in the trend line, the line that the best fit line through the scatter, it's positively sloped, right? So the growth rates actually are positively correlated with the initial position. That is, there is some tendency for the initially richer countries to grow faster in per capita terms. So this particular sample rejects the hypothesis of absolute convergence, right? Because if the hypothesis of absolute convergence was to hold true, then it would have been the other way around, right? So in the figure, we should have observed a slightly downward sloping trend instead of an upward rising trend. So this particular sample size, this 114 countries that we had looked into, this particular sample rejects the hypothesis of absolute convergence. Now, see, the hypothesis actually it somewhat fares better if we examine a more homogeneous group of economies. What happens when we look into a more homogeneous group of economies. This would be the trend. So this particular figure 1.8 in Barros-Allais-Martin, this figure shows the results if we limit our consideration to 18 relatively advanced countries, that countries that were members of the Organization for Economic Cooperation and Development, OECD. So these are solely OECD countries that we are looking into from the start of the organization in 1961, right? So you would not find Germany in this data set, because Germany is omitted because of missing data, and Turkey is omitted because it was not an advanced economy in 1960. So these two economies you won't find here. These two, I mean, nowadays these are very much part of the OECD economies, but these two countries. But in this particular data set, we have to do without Germany and Turkey. But anyway, otherwise this is this is a pretty compact data set, right? So in this case, the initially poorer countries did experience significantly higher per capita growth rates. So we are doing a similar exercise, and here, you notice a clearly downward trend, a very conspicuous, very clear downward trend, right? So what we can definitely infer is that the initially poorer countries did experience significantly higher per capita growth rates, right? So this, the whole concept of absolute convergence holds true. This data set strongly supports the hypothesis of absolute convergence. Okay, so this type of result becomes more evident if we consider an even more homogeneous group. Let's say the continental United States, right? Uh, and the continental United US states, the states of the United States of America, like the US, if you divide the US into different states, then that becomes a more homogeneous sort of sample, right? So if we do that, this is what we would get. This is the sort of trend that we would get. So a more clear downward sloping trend. All right. So what this particular figure plots the growth rate of per capita personal income for each state from 1880 to 2000. So 120 years data against the log of per capita personal income in 1880, right? So absolute convergence, meaning that initially poorer states growing faster in per capita terms, holds clearly in this diagram. We can clearly notice from this diagram that the concept of absolute convergence holds true. That is, the initially poorer states are growing faster in per capita terms. So what we can do is we can actually accommodate the theory to the empirical observations on convergence if we allow for heterogeneity across economies. In particular, if we drop the assumption that all economies have the same parameters, it's not a very realistic assumption, so to say. So if we drop that particular assumption, and therefore, we are assuming that economies do not have the same steady state position. So if that is the case, so if the steady states differ, we can we might have to modify the analysis to consider the concept of conditional convergence, right? So the main idea is that an economy grows faster the farther it is from its own steady state value, right? So everything is is relative to its own steady state value, right? So this is where the concept of conditional convergence comes in, okay? So this is the main idea behind conditional convergence. So the economy grows faster the farther it is from its own steady state, right? So suppose, let me show you a figure, be easier. So see, figure 1.10 in Baruselli-Martin basically illustrates the concept of conditional convergence. So what it does is it considers two economies that differ in only two respects, right? Firstly, they have different initial stocks of capital per person. So K0 poor is less than K0 rich, okay? And secondly, they have different saving rates. So S poor, which is small s poor, is the the saving rate or saving propensity for the poorer nation, is not equal to saving rich, right? So here we are, you know, we are considering economies which are not similar in terms of these deep parameters, right? So our previous analysis, okay, so what's the difference? I repeat, the difference is in terms of the initial capital to labor ratio and also in terms of the saving rate, right? So, for example, the saving rate of the richer country, you can assume that to be greater than the saving rate for the poorer country, which usually is the case. So this is a very realistic assumption, right? Also, initial capital to labor ratio for the poorer nation is lower than the initial capital to labor ratio for the richer nation. This is also a pretty realistic assumption, right? All right, so these are the two differences: K naught poor less than K naught rich, S poor is less than S rich. Okay, let's refer to the diagram. Now, our previous analysis implies that differences in saving rates generate differences in the same direction in the steady state values of capital per person. That is, K star poor is not equal to K star rich, right? So the steady state, obviously, since we are starting from different initial capital to labor ratios, our the steady states for the two nations would be very much different. See, the K star for the richer nation is greater than K star for the poorer nation, right? So in this particular figure, what you find is that these steady state values are determined by the intersection of the SFK by K curve with the common n plus delta line, because n plus delta is common for both nations. Let's assume, for at least for simplicity's sake. Okay, so although you might argue that poorer nation might have a higher population growth rate and higher n, but for the time being, let us assume that the population growth rate is same for both nations, and so is the depreciation of capital, the value of depreciation of capital. Okay, so n and delta are same. So we can have a common n plus delta line, and the point of intersection would differ, right? Hence, the steady state values of capital to labor ratio for the poorer nation and the rich nation would be different, right? So basically, what we do is we consider the case in which S poor is less than S rich, and hence K star poor is less than K star rich, because these differences very likely explain why K naught poor is less than K naught rich applies at the initial date. So it is also true empirically, as we had discussed before, that countries with higher levels of real per capita GDP tend to have higher saving rates, right? So so this is this figure is pretty consistent with that particular idea that countries with richer countries or countries with higher levels of real per capita GDP have higher, they usually tend to have higher saving rates, right? So the question is, does this model predict that the poor economy will grow faster than the rich economy? That is the question. Does the Solo model predict that poor economy will essentially grow at a faster rate compared to a richer economy? So see, if these economies have the same saving rate, then the per capita growth rate, which is the distance between the SFK by K curve and the n plus delta line, these sort of differences, these differences would be higher for the poor economy, right? And the K dot by K poor, that would be greater than K dot by K rich. So that this concept of growth rate of capital for a poorer economy greater than growth rate of capital for a richer economy would definitely apply. However, if the rich economy has a higher saving rate, as is shown in this particular figure, um, then what we would find is that the K dot by K poor is less than the K dot by K rich. This might hold, right? As you can find it in this figure. So here what you find is that this gap, look into this vertical distance and look into this vertical distance. So this vertical distance represents the growth rate of capital per labor for a rich nation. So the growth rate of capital per labor for a rich nation is definitely slightly higher for a rich nation as compared to a poorer nation. Poorer nation has lower growth rate of capital per unit of labor, right? So this is the idea that usually if economies have the same saving rate, then per capita growth rate, which is the distance between the SFK by K curve and the N plus delta line, that would be higher for the poor economy, and growth rate for poor greater than growth rate for rich would apply. However, in this particular figure, we have the growth growth rate for the richer economy to be greater than the growth rate for the poorer economy, because the rich economy has a higher saving rate compared to the poorer economy. This is the underlying difference, right? So richer economy has a higher saving rate, and if that is the case, then sometimes you might experience the richer economy to be growing at a faster rate compared to the poorer economy. As you find in this figure, the vertical distance for the richer economy is greater than the vertical distance for the poorer economy. Right. So the intuition is that the low saving rate of the poor economy offsets its higher average product of capital as a determinant of economic growth, right? The low saving rate for a poorer nation, basically it outweighs or it offsets the higher average product of capital as a determinant of economic growth. Hence, the poor economy may grow at a slower rate compared to the richer economy, right? So the neoclassical model does, actually the question is, can you find this sort of a result from the neoclassical model? Is it very common for the neoclassical model to sort of reproduce this kind of result? So basically the idea is that the neoclassical model does predict that each economy converges to its own steady state, and that the speed of this convergence relates inversely to the distance from the steady state. In other words, the neoclassical model basically predicts that conditional convergence, in the sense that a lower starting value of real per capita income tends to generate a higher per capita growth rate once we control for the determinants of the steady state. So what you can do is you can recall the steady state value K star, which depends on the saving rate S, the level of the production function, which is Fk. And we have also mentioned that sort of government policies and institutions can be viewed as additional elements that effectively shift the position of the production function. So the findings on conditional convergence suggest that we should hold constant these determinants of K star, small k star, to isolate the predicted inverse relationship between growth rates and initial positions, right? Initial position of capital. So what you should do is you should hold the determinants of K star to be constant, right? And why would you do that? You would do that in order to isolate the predicted inverse relationship between growth rates and initial positions. Okay. So now algebraically, you can also illustrate the concept of conditional convergence by returning to the formula for K dot by K. Okay, so we have already established the formula for K dot by K, right? The growth rate of capital, that was 1, 2, 3, equation 28 over here. Let me refer to that equation. So this is the equation. This is the relevant equation. So basically, what we have done today is we have looked into the idea of conditional convergence. So algebraically also it is possible for us to illustrate the concept of conditional convergence from this particular equation, right? So this would be our next exercise. So in the next class, we would be going through the derivation of convergence, the derivation of the concept of conditional convergence starting from this particular equation. Okay, so I'll talk you through the derivation, and after that we are going to also talk about convergence and dispersion of per capita income before we look into the technological progress. Technological progress is going to take a few more classes, but for the time being, let us focus on convergence. So next class we would be looking into the algebraic, derivation of conditional convergence starting from this particular equation. Okay, so from today's lecture, what we have established is the following. We started with this particular question, that does a poorer economy actually grow at a faster rate compared to a richer economy? This was the question. So a short and simple answer to that question would be yes, if the saving rates are equal. But if the rich economy has a higher saving rate, as was just shown to you in terms of figure 1.10, then the growth rate for the poorer economy is going to be higher than the growth rate for the richer economy. I'm not saying that this is always going to be the case, but this might sometimes happen, right? This might sometimes happen. Basically, when the low saving rate for the poor economy offsets the high average product of capital as a determinant of economic growth. Only then this would happen, right? So hence the poorer economy would be growing at a slower rate compared to the richer economy, right? So K dot by K poor greater than K dot by K rich might be true. That is, the rich economy can grow at a faster rate. So this is the idea, right? So the low saving rate of the poor economy offsets the higher average product of capital as a determinant of economic growth, right? So all right, so more on this in the next lecture, and we would be looking into the details of algebraic derivation of the conditional convergence. Okay, so more on that in the next class. So if you have any questions related to absolute convergence and conditional convergence, basic ideas, you can ask me now.